Hello friends, this is Amit, your mentor at mentorbuddy.com. Here we have a question on clocks and calendar. So we'll quickly see a question which says a watch which gains 5 seconds in 3 minutes was set right at 7 a.m. in the afternoon of the same day when the watch indicated quarter past 4 o'clock. True time is. We have been given 4 options and we need to choose one correct option. Okay, so here in this question you can see that it has been given that it is gaining 5 seconds in 3 minutes, right? So for every 3 minutes the clock is gaining 5 seconds, right? It means that when the correct clock is moving, when the correct clock is moving 3 minutes, the faulty clock will move 3 minutes 5 seconds, correct? So it is given that it is set right, that the faulty clock is set right at 7 a.m. in the morning. So in the afternoon of the same day when the watch indicated quarter past 4 o'clock, that is the fault. We are talking about the clock that is faulty clock which is gaining the time. It is showing quarter past 4 o'clock. It means 4:15 p.m. right? Quarter past 4 means 4:15 p.m. The true time is, so in the original clock the true time will be what? So here the question is somewhat reversed, that is the faulty clock timing. In most of the question the correct original time watch timing is given and it has been asked that tell the time of the faulty clock, but here the question is reversed, that the faulty clock timing is given and it has been asked that what will be the true time. So it's just a bit tricky question which we need to handle it. So just we'll understand the concept, that is let's suppose that if a clock is showing one hour, right? This is the correct clock, that is the original clock, and in every 1 hour if the faulty clock is gaining 1 minute, right? The faulty clock is gaining 1 minute in every hour. So it has been, now let's suppose it is given that after that at 6 p.m. when the faulty clock is showing, that is 6:05 p.m., then what will happen? If the faulty clock is showing 6:05 p.m., then what will happen? What will be the timing in what will be the true timing, right? If a question is like this, then what we need to, how we need to handle it? What we need to handle it, we need to see that in 60 minutes, right, the time difference is coming as 1 minute, right? That is time difference is coming as 1 minute, which means when that the faulty clock is moving 61 minute, right, the true time, that is the original watch will move 60 minutes, right? This will be the understanding. So similarly we will use the unitary method to solve the question, correct? So what we'll use we'll use the unitary method in our question, which says a watch gains 5 seconds in 3 minutes. It means if the faulty clock is moving 185, 3 minutes means 180 seconds, right? So if we are saying that for every 180 seconds, or you can say that for every 185 seconds, that is 3 minutes 5 seconds, for every 185 seconds of a faulty clock, the original clock will move 180 seconds, right? This is correct. Okay, so it has been given that in the morning 7 a.m. the clock is set correct, then the faulty clock is showing that 4:15 p.m., that is 4:15 p.m. it is showing, right? So what will be the original timing? So to come to this 4:15, how many, what is the timing which has been what is the, how many minutes or how many seconds this clock will move? This clock will move, that is from 7 to 4, the number of hours will be 9 hours, and the minute hand will move how much? 15 minutes. So in total how much time, how many minutes it has moved, it is moved 9 hours. It has moved, the faulty clock moved how much? 9 hours and plus 15 minutes, right? If we talk in terms of minutes, it will be how much? 9 into 60 plus 15 minutes, right? That is 9 into 60, 540 plus 15, that is in total 555 minutes. Okay, now we have this value, that is the faulty clock moved how much? 555 minutes, right? So we have seen from here, that is equation 1, we can say that for each 185 seconds the original clock is just moving 180 seconds. So if we this we have time in terms of minutes, so we can convert it into seconds, right? So we can use the method, that is we just need to multiply it by 60. So how many seconds will be there? 555 multiplied by 60. So from 7 a.m. to 4:15 p.m. how many seconds will be there which is moved by a faulty clock? 555 into 60 seconds. Okay, now we have this, that for each 185 seconds the original clock is moving only 180 seconds, right? So we can quickly use the unitary method to further solve this question, right? That is here, from here we can see that for each 185 seconds the original clock is moving only 180 seconds. So for each second of a faulty clock, the true original clock will move how much? 180 divided by 185 seconds, right? And for 555 into 60, as we have calculated total number of seconds from 7 a.m. to 4:15 p.m., that is 550 into 60 seconds. How much the original clock will move? It will move 180 multiplied divided by 185 multiplied by 555 into 60. This will be the total number of seconds which will be moved by original clock, right? This timing is in seconds, the total seconds. If we talk in terms of hours, how much the the true clock will move? So if we need to convert it into from seconds to hours, so we need to divide it by 60 into 60. So this will be the total number of hours which original clock will move. So we have converted the second into hours by dividing it by 60 into 60. Now we can solve it to find the total number of hours the original clock moves. 60 will be cancelled out. This we can cancel out, that is 3, right? 185 we can cancel by 5, that is 3 7, right? This we can mark it as 1 1 1, and 37 will be cancelled out with this as 3 times. So the final, it is coming 3 multiplied by 3, that is 9 hours. Okay, it means for 9 hours 15 minutes, this timing is how much? 9 hours 15 minutes of a faulty clock, the original clock will move how much? 9 hours. It means the difference is of 15 minutes. So for if the faulty clock is showing 4:15 p.m., the original clock will show how much? That is 4 p.m. only. Option A is the correct one. Okay, so student, this is a pretty easy question. I mean, it's a bit difficult question, but we can convert it into an easy method, that is unitary method. You just need to reverse it. That is, we need to just check that for each 185 seconds the original clock will move 180 seconds. Then we can follow the unitary method and we can get our answer. Okay, thank you everybody. Happy learning.